Alright, welcome back. Hopefully you had a good Thanksgiving. Today I want to cover some problems with complex numbers. So I'm going to show you the form here first, but how to write these terms. So you have A, which is your real term, and BI, which is your imaginary term, where I is just equal to the square root of -1. Therefore, I squared equals -1. So those will be useful in these problems. For the first problem, we have the square root of -25. So that's the same as saying the square root of -1 times 5 squared. So we can pull the 5 outside, so we get 5 times the square root of -1, which is equal to 5i. And to put it in the a plus bi form, in this case a would be 0, and then you have 5i. For problem 2, we have the square root of 3 times the square root of -4. So you have square root of 3 times the square root of -1 times the square root of 2 squared. So we can pull the 2 out. So you have 2 times root 3 times root -1. So you just have 2 times I times root 3. And then in a plus bi form, you have 0 plus 2i root 3. And you typically write the I in front of the square root instead of on the other side. I think it just looks better that way. That's why people do it. Easier to keep track of the i's. For problem 3, you can just distribute the minus sign. So you have 4 plus I minus 6 minus I. The i's subtract out. So 4 minus 6 is -2. And then for a plus bi form, you just say it's 0i. So -2 plus 0i. Problem 4 is just 1 plus I root 2 plus 8 minus 5i root 2. So 1 plus 8 is 9. And then you have I root 2 times 1 minus 5 if you factor out the I root 2. So that just gives you 9 minus 4i root 2. For problem 5, you just distribute the terms. So you have 2 times 3 minus 2i plus I times 3 minus 2i. So 2 times 3 is 6. 2 times minus 2i is minus 4i. Plus 3i minus 2i squared. So that gives you 6. Minus 4i plus 3i is minus I. And then I squared is -1. So we can change the sign in front of the 2. So you have plus 2. And your answer is 8 minus I. For problem 6, we have 5 over 2 minus I. When you have an I in the denominator, you want to get rid of it by multiplying the fraction by the complex conjugate. So you have 5 over 2 minus I. And the complex conjugate is just the denominator term with the I. But you change the minus sign into a plus, or vice versa. So you multiply by 2 plus I over 2 plus I. So you're still just multiplying by 1. So that gives you 10 plus 5i divided by 2 times 2 is 4 plus 2i. And then you have minus 2i minus I squared. So that gives you 10 plus 5i. The 2 i's subtract out. So I squared is -1. So you can just change the minus sign. So you have 4 plus 1. So you got 10 plus 5i divided by 5, which just equals 2 plus I, when you divide through the 5. For this last problem, we're going to do the same thing as problem 6, where you multiply by the complex conjugate. So you have 4 plus 3i over 1 plus 2i. And you multiply that by 1 minus 2i over 1 minus 2i. So 4 times 1 is 4, minus 8i plus 3i minus 6i squared. And that's divided by 1 minus 2i plus 2i minus 4i squared. So the 2i subtract out. So the numerator we have 4 minus 8i plus 3i is minus 5i. Minus 6i squared gives you plus 6. And that's divided by 1 plus 4. So we get 10 minus 5i divided by 5, which just equals 2 minus I.